we need to talk about this and why it has these despite having those. It's the Prusa Core 1, the long-awaited answer to Bambu, and their first factory-enclosed Core XY. It takes what they've learned over a decade of designing printers, builds on it, and packages it into a more modern form factor. A fast, reliable, and open source alternative to the walled garden of Bambu or the cheap clones of their competitors. Well, it's sort of open source, but also not really. We'll come back to that. This isn't the first video I've made about this printer, but it's the first since having hands-on time with it. What came before this, as you may recall, was a video titled "The Prusa Core 1 is Dividing the Internet." And well, it was dividing the internet. Some say it's Prusa's comeback, and others say it's too little too late. After all, Bambu had been eating Prusa's pie for quite some time. They'd gone from a fledgling company with an ambitious Kickstarter campaign to absolutely dominating the market almost overnight. In the meantime, Prusa released their flagship XL, which had some innovative features but was far outside the price range of most consumers. They'd still yet to release a reasonably priced, moderately sized, factory-enclosed Core XY. Then came the Core 1. At long last, Prusa was parting ways with the bed slingers of days past. But given how long it took them to get to that point, it seems like they may have already missed the boat. Bambu had released 3 consumer-focused Core XY 3D printers in the time it took Prusa to release 1. But then, in a twist of fate, Bambu announced a poorly received firmware update, further locking down their printers with the introduction of authorization control. Add to that the price increases on account of US tariffs on China, and it looked to be the perfect storm for Prusa. So did they capitalize on that opportunity? Well, that's what we're here to find out. And we won't be going easy on them. I'm going to put this printer through its paces and see what it's capable of. And of course, I'm going to be brutally honest about my findings. So much so that Prusa might regret sending this to me. And they did send this to me for free, along with 3 hats, a mouse pad, and a coffee cup, which, as I understand, is a notable departure from their previous philosophy on review units. They just didn't need to send them because their machines already got enough coverage organically. But the market has changed dramatically, and I guess they've changed their stance on that. The Core 1 has an all-steel frame, making it pretty heavy, with an acrylic panel for the front door and viewing windows on either side. These are held on by plastic rivets, as opposed to screws. These are generally meant to be one-time use, which means they might need to be replaced if they're ever removed during disassembly of the printer for maintenance. But they do send you with plenty of extras. On either side of the printer is a sunken pocket, one that is occupied by a spool holder and the other a blank canvas, a storage area for accessories or spare parts. The fully assembled version only requires you to install some rubber feet and attach the LCD bezel before you're up and ready to print. This is a touch screen, but you'll probably prefer just to use the rotary knob, especially if you have big fingers. The Core XY motion system uses 10mm smooth rods for the Y-axis, which are a little bit beefier than the 8mm rods used for the Y-axis of the Mark IV. In contrast, the smooth rods that guide the motion of the Z-axis have been stepped down to 8mm from 10, as on the Mark IV, making them equivalent in size to those used on the Mark III. But we've got 1 additional lead screw, for a total of 3, making it the most constrained Z-axis motion system implemented on a Prusa printer thus far. Even the XL, with its larger bed, only has 2 lead screws. The Core 1, which inherits the Mark 52 heatbed of generations past, is on the smaller size of the market in terms of build volume, with the same 250mm on X as on the Mark III and IV. But we do gain an extra 10mm in Y on account of the Core XY kinematics, for a total of 220. And in keeping with the old bed, the build plates are interchangeable. The X-axis rides on a linear rail backed by a steel extrusion. The remainder of the gantry is also comprised of steel, with 3D printed PCCF parts for the motor and pulley mounts. The printhead is the familiar Nextruder, first introduced with the Mark IV and since improved in various ways. The Mark IV Nextruder used PETG printed parts. The Core 1 replaces those with PCCF. In the S upgrade of the Mark IV, the cooling fan was switched from a slim one that pivots out of the way to this absolutely chungus one. There was a noticeable performance improvement, but it looked a little awkward. The Core 1 uses the same fan, but relocates it to the back of the toolhead with a redesigned shroud, a much cleaner aesthetic. Prusa claims that overhangs up to 70 degrees are printable, which they demonstrate with this Scandic plate model. It prints well, but the settings are a little cherry-picked. One of the innovations of the Nextruder was the introduction of new nozzles with an integrated heat break in a one-piece design. They're similar to Revo nozzles, but not nearly as convenient to change. It's a two-handed operation. To make things a little easier, you can print this fixturing piece to hold the heat block in place. The Core 1 ships with a brass nozzle, which is one of my big gripes up front. This is already a premium price printer. We shouldn't have to shell out more just to make it work with abrasive materials, which are becoming more and more common. And they're not cheap either, $50 US. Or if you want the high flow version, 65. I think I'll cry if this ever clocks. The direct drive extruder features a custom planetary gearbox, generating high torque in a compact footprint. This turns an oversized drive gear, which provides above average contact area with the filament. The Mark III, with its smaller Bondtech drive gears, was pretty sensitive to idler tension, particularly when printing flexible filaments. This seems to be a non-issue on the Nextruder. However, one thing I've noticed from my testing on the XL, which has a similar setup, is that the filament gets slightly compressed against the gear. If a filament like PLA that gets brittle over time with exposure to moisture is left loaded in the extruder, it will occasionally break at this point. The Nextruder, despite having a variety of fancy sensors like a heat break thermistor and a load cell, doesn't detect filament movement, only filament presence. If the filament is broken at this point, the printer will be none the wiser. It will just keep printing, but not extruding, which is definitely frustrating. Only one more thing worth mentioning here, and that's the toolhead breakout board. It's pretty much standard across all printers these days, but there was a time when every wire ran all the way back to the main board, requiring significant disassembly in order to replace components. So it's nice to have convenient access to these plugs. One thing that isn't convenient is the installation of the optional camera. It requires partial disassembly of the printer. On top of that, it's a $40 upsell. Only takes snapshots, doesn't stream video, and here's the kicker. It's only accessible through the cloud-based Prusa Connect. Wait a minute. I thought this printer was usable in offline-only mode without any compromises.
You can run the printer in a fully fledged offline mode. We will never force you to connect the printer to the network.
Well, apparently not. You gave us an Ethernet port. Thank you. More than can be said for some other brands. You gave us a removable Wi-Fi module. Okay, cool. That will be some added peace of mind for those that want the extra security. Why then is the camera feed not accessible through the LAN-based Prusa link? It's quite apparent that many more resources were dedicated to developing the cloud-based Prusa Connect versus the LAN-based Prusa link. Prusa Connect is feature complete and has a nice UI. Prusa link is still in beta. I get that Prusa is trying to offer the same cloud conveniences as their competitors, but that shouldn't be done at the expense of one of their primary value propositions, offline printing. But I digress. For better or worse, cloud services are becoming increasingly popular. But do you know how they work? When there's a topic I want to learn more about, I often turn to Skillshare, the largest online learning community for makers, designers, and creatives, and the sponsor for today's video. Lately, I've been trying to improve my skills in 3D modeling by watching courses on Fusion 360. I particularly like the one by fellow YouTuber Austin Hartley. He teaches from the perspective of 3D printing, accounting for the unique constraints and necessary considerations for this type of design. If you're interested in turning your passion for 3D printing into a side hustle or a full-time gig, Skillshare also has great courses on launching an Etsy store, from creating your first listing to getting your first sale. With thousands of inspiring classes across design, technology, and business, Skillshare can help you learn new skills or improve on your current ones. The first 500 people to use my link in the description will receive a 1-month free trial of Skillshare. Get started today and take your 3D printing and design skills to the next level. Okay, I think it's about time we got to printing. The Core 1, like the Mark IV and XL before it, uses the nozzle for probing. On one hand, this is convenient because it allows you to print on any surface without manually adjusting the Z offset. On the other hand, it's error prone because any nozzle ooze will affect the calibration. I'm of the opinion that a nozzle wiping solution should be a prerequisite for nozzle probing, but alas, the Core 1 doesn't have one. And I did experience a few nozzle cleaning failed errors during my testing, requiring intervention. That said, the first layer was about as close to perfect as we could hope for. And this, friends, is why you shouldn't touch the build plate with your greasy fingers. The first couple of prints were great. A Robo Alpaca in Prusa Galaxy Silver, and a print-in-place phone stand in Prusa Galaxy Black. Well-tuned profiles are one of the biggest assets of Prusa printers. If you're coming from Bambu, you've already been spoiled. But there was a time when you'd have to do the tuning manually. Temperature, retraction, flow rate, pressure advance, etc. It could be a real burden. Prusa does it all for you. They've even gone as far as having conditional logic for pressure advance based on nozzle size. I then ran a test to identify vertical fine artifacts. This is where things got interesting. The Core 1 has 0.9 degree stepper motors, as opposed to the usual 1.8. The finer step resolution yields smoother motion, resulting in less motor resonance, the leading cause of VFAs. The severity of VFAs depends on the movement speed and direction. This test can be used to identify the VFA maximizing speeds so those can be avoided. As long as the profiles are tuned accordingly, we'll be happy. This print using the 0.2 speed profile was VFA free, but it was also quite matte at those speeds. Glossy prints will show the issues much more clearly. And there they are. Given that these artifacts match the pitch of the belt, 2 millimeters, these are what I'd call type 2 VFAs. They're not caused by motor resonance, but rather the interaction between the belt and the pulleys. The teeth on the timing belt are thicker and thus harder. The gaps are thinner and thus softer. When driven by the pulley, the hard section bends less, and the soft section bends more. This is the so-called polygon effect, which makes the movement non-uniform, resulting in this distinct pattern on the surface of your prints. Most printers exhibit this to some extent, but they seem worse on the Core 1. From left to right, we have the Prusa Core 1, Bambu X1C, Prusa Mark IV, and Qidi Plus 4. The Plus 4 is the best among them, which matches my findings in my review of that printer. Although at the time I did a terrible job of explaining why that was the case. The smaller 1.5mm pitch of those belts reduces the prominence of the polygon effect. Imagine it like a pentagon versus an octagon. More sides, higher resolution, smoother motion. But the rest of these printers have 2mm pitch belts, so I'm honestly not sure why the Core 1 result is so much worse. On recommendation from Prusa support, I tried retensioning the belts to see if that would help. Using the belt tuning utility in the Prusa app, I plucked the belts at mid-span and adjusted tension until both belts were at 85 Hz. Unfortunately, there was no improvement in print quality. And I'm not alone in this finding. There's a pretty lengthy thread on the forums from users that made similar observations. This reminds me a lot of the layer stacking issue I observed on my early adopter XL. I came up with a janky solution to fix it, but in the end, it turned out that simply greasing the couplers on the front of each tool would achieve the same effect. Hey, so I have an update on the VFA situation for the Core 1. In speaking with Prusa support, they initially recommended I double check the belt tension was a nominal 85 Hz, which it was within reason. With the VFA still present, they then recommended I increase the tension all the way up to 105 Hz, 20 Hz above the normal recommended range, and outside the range that their belt tuner app can even register. Well, lo and behold, that had a significant impact in reducing VFAs. I don't know that it's necessarily a long-term solution because there may be adverse effects on the motors and other motion system components from having the belts tensioned so tight. But in the short term, at least we have a solution to get some better looking prints. And Prusa has assured me that they are still investigating the root cause. Moving on from the benchmarks, I printed something practical, a bed full of parts for a project I'm working on. The Prusa Core 1 handled them with ease. This is why Prusa printers have earned a reputation as reliable workhorses. I'm quite confident that this printer could crank out beds full of parts like these on a daily basis over a course of multiple years with little need for maintenance or intervention. I know this because my 5-year-old Mark IIIs are still going strong. Check back with me in 5 years and I'll let you know if the Core 1 is too. Print quality was good overall, but I did notice some horizontal banding. And if you look closely, you can see some of the vertical fine artifacts I observed previously. I wanted to directly compare the layer stacking consistency with that of the Mark IV, so I printed a tall cylinder in vase mode. This gives you a good visualization of the max print height difference between these two printers. Ignore the small layer shifts. Those are just a result of printing a thin, tall structure in vase mode. Apart from that, the layer stacking was consistent. There is no banding per se, but there is a characteristic pattern to the layers that is more prominent than on the Mark IV. The Mark IV, being a bed slinger, gets unstable towards the top. The Core 1 is consistent throughout. This is one of the inherent benefits of a Core XY motion system. I'm not sure how to explain the different characteristic of the layers. It could be coming from the Z-axis motion system or the extruder. I'm not sure which. The Core 1 uses the same Nextruder as on the Mark IV, so the Z-axis seems more likely. Running the same test on the XL, the layers looked more similar to the Mark IV than the Core 1. I also ran a VFA test and found that the XL print looked better, but not perfect, with some evidence of belt-induced VFAs. Next was a TPU test. I first tried the softest filament I had on hand, 60A on the shore hardness scale. Well, that was a non-starter. I couldn't even get it to feed through the first filament sensor. The Core 1 has two filament sensors, one on the tool head and one where the filament first enters the printer. I then tried a much firmer 98A TPU, which fed in without issue and printed fine. ABS was my next adversary. According to the spec sheet for the Core 1, ABS printing requires the air filtration upgrade. The printer comes stock with two exhaust fans, but there's no filter medium to capture fumes or particulates. This is another example of what feels like an unnecessary upsell. For the price of this printer, we shouldn't have to pay another $75 just to protect our health. After sending the print and before it started, the printer waited for the chamber to reach a temperature of 40. This took about 10 minutes. It then waited another 5 or so minutes for the bed to heat soak before probing. These are important steps that a lesser printer would breeze through, causing issues. So this is well done by the firmware team. The pockets on the side of the printer don't just make for convenient storage. They also help reduce the interior volume, allowing the air to heat quicker. When printing ABS, the maximum chamber temperature is disabled, so the exhaust fans never kick on. In order to retain the most heat, you'll also want to close the ventilation grill on top, which is a manual process. Contrast this with the H2D that has an automatic opening ventilation flap, and this feels a little under-engineered. But at least we have the ability to vent heat without leaving a door open, which is more than can be said for most printers. For some reason, instead of displaying the current chamber temperature, the LCD just displays off. The only way to know the current temperature is to navigate deep into the menu system to get the sensor info. You can also view the chamber temperature in the web interface, but only through the cloud-based Prusa Connect, not through the LAN-based Prusa Link.
You can run the printer in a fully fledged offline mode.
Things were looking good, but I noticed some buildup on the nozzle. I paused the print in order to clean it. When I resumed, it seemed to lose the Z height, knocking over the supports and digging into the previous layer. Seems like a firmware bug. So I canceled the print and tried again. This time the result was great. Sharp details and no warping or layer separation. I did, however, notice that belt-induced VFAs were still present, even on this fairly matte filament. Moving on to something a little more engineering grade, I loaded some carbon fiber nylon. Maybe it was just out of spite because this is Bambu Lab filament, but I was having some issues with the filament sensor not detecting the filament properly. When I clicked yes to continue the print, then clicked continue to load the filament, the printer tried to load cold without the extruder preheating. Another firmware bug. I swear I told it I was loading nylon, but when I went to send the print job, I got a warning about a filament mismatch. It thought I had PETG loaded. Unfortunately, there was no way to update the filament mapping without unloading and reloading the filament, which is quite inconvenient. So I just ignored the error and sent the print anyways. The Core 1 can be upgraded to print multicolor, which is becoming somewhat of a standard feature these days, but there are some caveats. You can retrofit it with the MMU3, but it's not nearly as simple as plugging in an AMS to a Bambu printer. It also significantly increases the footprint of the machine on account of the required filament buffers. On the bright side, it's more efficient than any other AMS type system, on account of the fact that it retracts the material all the way out of the melt zone rather than cutting it off at the top of the heat break and purging the rest. If Prusa can refine their design to make it more compact, as in this concept they teased, it could be a viable alternative to Bambu for efficient multicolor printing. But until then, the Core 1 will be best known as a single color printer. So all in all, the Core 1 does a nice job of printing most materials. It offers a polished user experience that is easy enough for beginners and versatile enough for advanced users. But the presence of firmware bugs negates from the experience, and in some ways, I found the print quality to be worse than the Mark IV. But perhaps the biggest asset isn't what this printer is, it's what it's not: a walled garden. But it isn't a wide open field either, and I believe that fact might be lost on a lot of people. Prusa printers used to be entirely open source: hardware, software, and firmware. Nowadays, it's mainly just software and firmware that's available to the public, with hardware access being limited. They used to release step files for the printed parts. Now they just release STLs. They used to use open source electronics. Now that they make their own, they've kept them proprietary. Custom firmware used to be easy to install. Now you need to physically modify the control board in order to allow it. At one point, this would even void your warranty, but they've since changed their stance on that. But hey, I get it. I really do. I can only imagine how demoralizing it must be to see your R&D efforts taken advantage of by your competitors with zero compensation. This business model might have been valuable in the early days of the RepRap movement, but it's not now. And Prusa has acknowledged that. But in spite of that, they're doing what they can to remain open without handing their designs to their competitors on a silver platter. Case in point, the swing arm, a much more convenient solution to cable management than the traditional cable chain. But as necessary as it may seem to protect their innovations in this increasingly competitive landscape, doing so changes the dynamics of the company and its position in the market. For many, the open source nature of Prusa's products is what makes them worth spending the extra money on. You feel like you're helping fund the efforts that are pushing the industry forward, rather than simply lining the pockets of a greedy corporation. This goodwill affords them some leeway when a shipping date slips or a firmware update introduces a new bug. But now that their printers aren't fully open source, they shouldn't be afforded the same concessions. And there are concessions. The shipping of the camera and nozzle I ordered took a few weeks, and I encountered a variety of firmware bugs in my short time of testing. I, like many others, want to see Prusa succeed, so I hope they take this feedback in stride and use it to make their products better. But I'd love to know what you think about this printer, about Prusa as a company, and about the trajectory of the 3D printing industry as a whole. Let me know in the comments down below. And if you enjoyed the video, please give it a like and consider subscribing. Thanks for watching. My name's Taylor, this is YGK3D, and until next time, happy 3D printing. Hey, me again. Thanks for making it to the end of the video. I just wanted to say that even though this may have come across as quite a pessimistic review, I'm actually really fond of the Core 1. I find myself holding Prusa to a higher standard because they charge a premium for their products and they've been in the market for a long time. So when they make some mistakes or their products are a little rough around the edges, I tend to go a little bit harder on them than I would a new brand that's just learning. But all in all, the Core 1 is honestly a really great printer. And I know it'll evolve over time and they'll iron out some of those bugs and it'll be a workhorse for a lot of people. So I just wanted to clarify that. I'm not completely ragging on Prusa in the Core 1. I do think it's a good printer. I just think they made some mistakes along the way.